Okay, good afternoon, ladies and gentlemen. Welcome to Steelix Industry 4.0 webinar series. Okay, we are an authorized partner of RWTH Aachen University, one of the top university in Germany, pioneering in Industry 4.0. We have provided trainings and consultation to numerous companies since 2017. I would like to thank you for your interest and participation, and I would like to welcome back for those who have participated in our webinar series Part 1 and Part 2. Myself is Raghavan Krishnamurthy. I'm the Malaysia rep for RWTH International Academy and will be your moderator for the webinar. Today we will discover part 3 of 5, and the topic is data analytics, the enabler of change and progress for your organization. I'm sure you are quite familiar with our distinguished speaker, Dr. Hoffmann from Germany by now, right? However, allow me to give a brief introduction again about him, right? Dr. Max Hoffmann is the head of digitization and digitalization, manager at the Institute of IPT, Institute of Production Technology, or in short IPT, which is part of Fraunhofer Research Organization. For numerous years, he has been leading the Industrial Big Data Group at RWTH Aachen University and managed major projects with German manufacturing industry. Dr. Hoffmann conducted projects on digital transformation with many large-scale German and international companies such as Volkswagen, Porsche and Gobin, and Bosch, to name a few. Today, he will be giving a talk for 45 minutes, followed with another 45 minutes allocated specially for Q&A session. However, please do not hesitate to stop him halfway if you have any questions. Just feel free to unmute yourself to interrupt him. I guess he'll love it that way, right? Okay, so otherwise, you can still raise your concern or questions in the chat box. My team and I will compile them, forward it to Dr. Hoffmann on your behalf during the Q&A. We will try our level best to cover all your questions as much as possible. And yeah, one more request. It would be great if you can turn on your video throughout the session, if you are comfortable, so that our speaker won't find himself talking to a laptop, right? So without further ado, here's our speaker, Dr. Hoffmann. The screen is yours. I guess you are muted.
So thank you, Raghavan, very much for the introduction. Welcome everyone back who has already seen me, and welcome to those who are here first time. I hope you've also checked out the YouTube channel and the Facebook channels that we have. So let me just start to the presentation after these kind words of introduction. So are you able to see my screen now? Are you seeing my screen now?
It's
my presentation?
No, not yet. It's still black, dark. Yeah, good.
Okay, perfect. So welcome again, and today's topic is data analytics, and we will talk about the enabler of change and progress for your organization. So I will talk a little bit about what data analytics can do for you, what it is, and how we can use it to optimize our processes. If you might have read the introductional text, then you already seen that there's some companies that are successful in digital transformation, and especially in the digital age. Yeah. And these companies, some of these companies are here. And if you look at these companies, you see that most of them aren't even so new. In fact, Amazon is more than 25 years old. Netflix is closely that old, and Google is also not that new. Yeah. So, but what makes this company real different to the other companies who don't make so much money and who are not so successful? The answer to this is these companies, they have understood what digital transformation means. And they have pursued this change along their way. Let's take Amazon. 25 years ago, Amazon was a bookshop, a physical bookshop where you could buy real books. Yeah. Now you can still buy books with them, but of course online. Yeah. When then the internet, the rise of the internet took place, and companies like Amazon and Netflix saw themselves in a couple of years, they anticipated that in order to stay competitive, you have to change yourself. Yeah, you have to transform yourself. Others, like these companies like Google, Airbnb, Uber, and so on, they are digital natives. They didn't really there was really no need to transform themselves because they were already digital, but they all understood the high value of data. Another interesting fact that all these companies, or most of these companies here, have in common, that most of them don't really have physical infrastructures or physical goods they sell or they rent or whatever. For example, Airbnb is the biggest hotel chain without owning a single building. Uber is the biggest taxi enterprise without having a single car in their possession. Yeah. And what these companies do is they are able to bring people together through data and to use data analytics to understand people they use their platforms. And understanding the people is something similar like understanding your process, right? So what I want to show you in this session today is how you can understand your process better, how you can optimize your manufacturing in the same way as these companies optimize their business. In addition to that, I would like to bring this quote, which was made a couple of years ago already by the president of the German information management community. Yeah. He said, coping with digital change is one of the most important management tasks of our time. If the business model changes as a result of digitization, the company must adapt or will disappear sooner or later. Machine learning. Yeah. Deep insights by automatic learning mechanisms. How do we do that? So let me firstly give a brief introduction in what machine learning is, or even how AI is defined. Yeah. Starting from here, we gather big data. We would like to transform this big data into smart data, and from there we want to derive decisions. And as we know, information is the oil of the 21st century, and analytics is the combustion engine. So starting from big data, we need to find smart ways in order to transform them into smart data. This is what you learned already in the last session we talked. Then going from there, from the smart data, we need to derive the decisions that can help us optimizing our process. And this step from the smart data to decisions, they are made by data mining or machine learning or data exploration. And these methods that allow this decision making, this smart decision making, these are summarized under the term of artificial intelligence. So what really is AI? If you look in the encyclopedia what AI means, then you find that AI is the ability of a digital computer or a computer-controlled robot to perform tasks commonly associated with intelligent beings. Yeah. Another definition, which is quite catchy, is artificial intelligence is a study how to make computers do things at which at the moment people are better. And this is one of the main characteristics of AI. Things that are easy for humans, for example, like walking, yeah, or moving, are especially hard for computers to reach. And things that are very hard for humans, for example, making big calculations with numbers, are usually very easy for computers. So what we characterize as AI is to make the computers good in operations in which we humans are better right now. Another very nice quote here comes from one of the founders of AI technology. He says, as soon as it works, no one calls it anymore AI, because it seems so natural. The movements or the operations of the robot or of the machine, it seems so natural that is almost human-like. And then nobody even sees anymore that it's AI, even though there is a huge and super good functioning AI behind it. So what is the key question? What does this really mean, intelligence? Yeah. Can we emulate intelligent behavior in machines, and how far can we take it? When we look back of AI, we go, in fact, back to the 60s. Already back there were first, for example, chat systems which were trying to emulate AI systems. Yeah, and the Turing test, which was shaped by Alan Turing, who also famously introduced the so-called robot laws. Yeah, the constraints for robots to not be endangering humans. This Alan Turing guy, he designed the first test, and the test is simply that you talk to somebody behind a wall and you don't know if it's a computer or not. If you can distinguish between a human responder and a computer responder, then it's not considered to be an AI system. If the user cannot find out if he's talking to a human or to a computer, then the system is obviously capable of AI. Now the definitions of AI has changed a little bit, but the general emulation part still is in charge. So how do we make a computer do smart things? Yeah. Obviously, as seen in the top right here, it's not possible to make a computer teach himself that easily by just reading a book or something. A computer will not learn how to talk like a human by reading a book about it. Yeah. So what the computer needs to accomplish, is to, based on their perception, is to develop something like a cognition, and from there to derive some actions. Yeah. So this cognition is usually reserved for the human brain, but modern approaches of AI actually used to imitate the brain functionality and the training of the human brain within a robot or within a computer. And we will see an example later how this might work. So let me give you a few examples of systems which might be AI or which might be not AI. Yeah, some of you might remember old computer games, for example, Space Invaders at the top right here. These kind of games, they were also emulating smart behavior. Yeah, and a computer who would be able to play this game, my question is, would he be considered to be smart or even AI? The answer to this question is no, because a computer which plays this game has a determined action in every single situation. So the computer doesn't need to make up his own rules. Hence, he can play the game only by rule-based approaches. This is why this computer playing this game here on the top right is not considered to be AI. The game on the left bottom goes already a little bit further. Yeah, there a computer is taught how to play football. And when you see at the sequence here, which I just showed, is you see that, for example, as the player, you can place yourself in front of the goalkeeper and just wait for him to shoot against you. The fact that you can repeat this as often as you want also tells us that the computer opponent here is not really AI capable, because if he would be, he would actually learn rules how to prevent this thing to happen. But since you can do it again and again, this means that the computer will not derive their own rules and will not define a smart way of dealing with certain situations. And this already tells us very clearly what AI is. AI is the ability of a computer or a robot to define their own rules, to deal with situation in a smart way. So how can machines learn, basically? The way machines learn can basically split into two categories. The first one is a data-driven learning, and the second one is a trial and error learning, the so-called reinforcement learning. We will look at both of these approaches briefly now, and then I will give you an example from the industry where we could combine those approaches to achieve a prediction model. So let's look at the data-driven solutions first. One of the approaches here, which we use to perform machine learning or AI-driven learning, is a so-called supervised learning technique. The supervised learning technique is able to classify objects when he's seen a lot of them based on certain labels. These labels tell the computer what, for example, this picture here represents. For example, if you train a machine learning model, a supervised learning model with a lot of pictures from fruits, for example, apple and pears here, and tell him also what this picture represents, hence an apple or a pear, then a computer will learn certain patterns and will learn how a typical apple looks like or how a typical pear looks like. The classification model, which results from the training with this data, will then be able to classify new unseen pictures with a certainty, with a certain percentage value. For example, the pear on the top right here is considered to be, he's 94% sure that this is actually a pear. Where might the 6% be? Maybe he has not seen any pear which is a little red. For example, the red parts of the pear, maybe some parts of the AI think it might be an apple anyway. So there's usually not 100% accuracy, but for most applications, it's sufficient when the accuracy is about, let's say, 95%. And as you see in the bottom right here, even the apple of the company is considered 62% or is classified with a certainty of 62% as an apple. Then there is, how does this work actually, this classification of an object? What the computer does is he takes this object, he extracts a so-called feature vector, which represents different values or visible measures that you can detect on this object. It might be the diameter on the bottom, it might be the thickest diameter of the pear here, or it might be the diameter on the top, it might be the overall length and the shape maybe. So all these features can be used as a feature vector, and this feature vector will then be put into this artificial intelligence model, into our machine learning model. And then we can, from there, use different algorithms to make sense out of this vector. So we can try to find a representation here of this object, and based on that, we can calculate a certain probability vector. And this probability vector will give us different percentage numbers, how sure the computer is which class this object has to be attached to. For example, with the pear, it was, in the example before, 94% pear, maybe 5% apple, maybe 1% something else. So the computer who gives us these probabilities is trained, and he's able to do this with stunning results. Another example of machine learning is so-called unsupervised learning. It works similar to the supervised learning, but unsupervised learning means we don't have labels. So the computer will not be able to put the, let's say, pictures which he processes into predefined classes, because we don't have predefined classes. The computer will instead find so-called clusters. So he will group objects which are similar together. Let's take the example here of this pictures of these actors on the bottom left here. Say you see a couple of male actors and a couple of female actors, and without even knowing that these actors, that these pictures here represent men and human, because we don't provide any patterns or any labels to the computer before, the computer will find certain similarities in some of the pictures. It might be certain characteristics of a man's face or women's face, which are very specific, for the gender. And based on this, the computer will be able to group these pictures into clusters. Then, of course, a human being afterwards could say, okay, this cluster refers to a group of men, and the cluster below refers to a group of women. But this clustering is not to be confused with the labeling. We only able to group the pictures by the computer and not name them. So how does this reinforcement learning work? This trial and error learning? This usually works with neural networks. And these neural networks, they are the representation of artificial brains. And I only will show very briefly how they work, because we have another session which is just on these AI networks. But let me say this: the feature vector, which comes in the left here as the input, is processed using a hidden layer, which represents the topology of the neural network. There are specific activation functions for each neuron and specific weights which connect the neurons with each other. Based on that, the computer will be able to learn from the input data and generate some output data, which might be a prediction or a certainty vector like you've seen before, the 94% peer and so on. So how does this reinforcement learning or learning by doing work? And here you see an example of a video game. In fact, most modern AI algorithms start developing with games, because games are quite complex, and actually pictures of games are quite complex to process for a computer. Here you see an example how a computer learns to play Super Mario World on old SNES game, and he only receives the picture and the actions he can perform. So the picture is the pixels here we see, and the actions to perform are actually left, right, jump, duck, and so on. And what the computer basically does is, first he plays totally randomly. He just runs around. He will die very soon, and but when he dies, he will always be he gets negative points. Punish points. And when he survives a couple of seconds, then he gets bonus points. And this is the way you train a artificial neural network for reinforcement learning. The idea is the same idea than teaching a kid when it's young, because a kid, when it learns to walk and it falls down, it hurts. So this is a penalty. It's a natural penalty. So in the end, the brain of the kid will learn how to work properly, so it doesn't fall anymore, so it doesn't hurt anymore. The principle of reinforcement learning when a computer learns to play a video game is precisely the same. The computer will make some random movements, and we'll see how they turn out, if they turn out good, if they turn out bad. And after a certain number of generations, you see this here, after letting the computer play the game maybe thousands or even million times, then the computer will become very, very good in this game. And he will be able to play this game very, very precisely. So in the end, the computer will play maybe the game way better than any human could play this game ever. And the magical thing of this approach is the computer never knows that he plays a video game. He only does it and goes for the maximum reward points on the lowest penalty points. So this is basically the way how computers work. Summarizing the different methods of machine learning: supervised learning, the unsupervised learning, and the reinforcement learning. All these approaches can be used not only for games, not only for, let's say, natural language processing, they also can be used for manufacturing, and they also can be used for data that is generated in a factory. But what sort of scenarios can we reach in our company, in our manufacturing by this AI algorithms? So what are really the application areas that we have? Of course, to stay internationally competitive, we're trying to reach the so-called batch size 1 production, which means that every product needs to be unique. To do this, we actually need flexible manufacturing system. We need fast and production systems with the high OEE. So we need self-learning commissioning, automated robots programming, self-optimizing production units, optimizing the production cycle. Yeah. Besides that, besides the manufacturing field, we also, of course, needs to target the management. So we need, for example, the prediction of global sales in the market. We need some knowledge transfer between humans and computers so that the computers can learn from us in order to make their production or their manufacturing complete. All these applications can be tackled by modern AI solutions. Yeah. And some of the use cases which we see in production, that we find in production, I would like to show here. What we can reach actually is shorter delivery times. So, for example, we can have a production of a customized product. We can have a more robust production because production units autonomously learn to deal with exceptional situations. We can have a better usage of working hours because we can plan them better and we can plan the collaboration between humans and robots better. Of course, through decision support by robots or by computers, we can also reduce human errors. Yeah. When we increase the use of intelligent robots, let's say for redundant tasks, then this also means that we can reduce human errors here. Which does not mean, and let me state this very clear, that we would like to replace humans by robots. What we would like to do is actually that the robots take over the redundant tasks, which no human would like to do, or which would be even harmful for humans to do on a long term. We would like to automate human workforce as well, make safer working conditions, lower our overhead costs by getting, for example, pre-trained robots, and design new variants of the human role. And especially the last one is very important because there is often a critic that AI or robots will take away human workforce, yeah, or will make the human being not anymore needed in a factory. In my belief, this is not true because robots will only help us in a way that will transform our role in the company. That means we can focus on the higher tasks and we can have more responsibilities and we can have different roles in a factory. And this doesn't mean that we will get less workers or less work to do in the factory as well. So what are applications of machine learning? Yeah? Before I bring you the industrial example, which I already talked about before, I would like to give you a couple of more examples from the real world where AI or machine learning is already used. Yeah, for example, these companies here are quite well in using this. For example, Waymo is used for autonomous driving. IBM Watson was designed to was the first world champion in chess actually when he beat Kasparov in 1997 with the Deep Blue computer. And we have these applications, for example, which are used by Facebook, which is face recognition. Yeah, these are all application areas of AI today. In the business sector, especially Amazon is very good in using AI to, for example, design their recommendation engine. This is when Amazon, for example, or some other shopping website will recommend certain items based on the items you already have in your basket. So how does, for example, Amazon do this? Yeah, and to state how important it is, let me say that Amazon actually makes 35% of the sales based on the smart recommendations they do. So there's two basic filtering techniques here. Yeah, the one is the item-based filtering. Yeah, this is actually bringing the profiling, profiling based on similar items that humans buy. For example, on the bottom right here, you see that the third person on the bottom gets recommended to buy the blueberries because this is the same items which were bought together by the other people. The user-based filtering tries to make a profile of the people and not about the product. For example, you can see that the person on the left top here has bought all these fruits here, the blueberries, the strawberries, the melon and the orange. Yeah. So the person on the bottom will get recommended this as well. These are simple algorithms, but they turn out to be very complex in practice. And this is actually also something that can be used in a production, yeah, by finding patterns, finding similarities between processes, between products, between production steps. Another example is the recommender engine, for example, for targeting customers in supermarkets. So what big supermarkets do right now, based, for example, on bonus cards or whatever, they create a unit target ID of the customer, which they like to characterize. So in the next steps, they try to bring customers into profiles. So they, for example, create some profiles, for example, people with the high wages, people that are about to get married, also maybe unemployed people, even pregnant women. They can profile based on the shopping behavior that they have. Yeah, and based on that, for example, they can provide coupons or give away coupons. And this is a way supermarkets already make money. Yeah, they understand the behavior of their customers, and based on this understanding, they create certain profiles of them. And based on these profiles, they can give precise recommendations or coupons, which will skyrocket their sales. So let me give you one example from the industry where this AI techniques can actually be used. And this example was carried out with a company which you might all know from the cars, which is called Audi. And they have a certain process. They have a certain process, which you see on the top right here. It's a press which basically manufactures large components of a car. For example, the car body, yeah, the roof of the car or the trunk. They are produced by the so-called deep drawing process. And the problem is the deep drawing tool, which you see on the top right here on the top of the picture. The deep drawing tool, which is basically the press that goes down, is very expensive. It costs about 1 million ringgit. Yeah, so if it breaks, it is very expensive. Not even mentioning the downtime, because usually there's only one or two of these presses in each huge production line, and when the tool breaks, no car can anymore more produced, and this will be with tremendous losses in revenue for these companies. So we did a project here where we had the task to predict based on some data, based on some sensor data, if a crack in the car component, for example, in the car body appears, and then if there is a crack appearing, which could endanger the health of the tool, which will be pressed down from the top to the bottom, then we will stop the press to prevent damage. Yeah. So the goal here was the prediction of the crack formation of the sheet metal before it actually happened. So based on the certain deformations in the steel, we would like to predict a crack before the crack is even there. Yeah, and if you see the curve, for example, you see the strain in the steel on the bottom left here, then you see that it's not so easy to really find out what the signal is doing. At least not for the human eye. It's not easy to see here what the signal wants to tell us, or if there's any pattern in the signal which could lead to a crack. On the bottom left here, you see actually a curve of a normal production process. On the right one, you see one curve where a crack occurs. And as you can see, after 500 milliseconds here, that when a crack occurs, the strain goes down very sharply for a short while, and then the strain will go up very fast, very high. And this is a crack. This is characterized as a crack in the steel, and this crack will tremendously endanger the tool, which we don't want to break. You can also see that the decision making here needs to be quite quick, because the whole process takes about 0.65 seconds. Yeah. And we only have the first, let's say, 300, 400 milliseconds to determine if there will be a crack appearing in order to stop the press. So how do we do that? Yeah, we built up numerous neural networks here, and we built numerous functions and AI cores in order to deal with this problem. Yeah. For example, we did a transformation of the strain signal, which is a wavelet. Yeah, we have several processes here based on different sensors. For example, on a laser sensor and based on a strain gauge. Yeah, so based on that, we could do the so-called upstream crack classification, which we performed with a so-called long short-term memory network, which is a specialized AI artificial brain, which is able to deal with time series data. Then we also used several filtering techniques to filter the signal, do some FFT here. Yeah, do some local differentiation of the signal to find out the signal's slope. Perform some Butterworth filter, and in the end brought it all together to our forecasting model, which was another artificial brain. So based on this complex design of this artificial brains here, we were actually be able to predict the happening of a crack based on the green line in the diagram on the top right here. So the known data set was only the green line we had. And on the right part here, you can see in blue line actually the prediction of the strain, of the tension in the steel based on the data and based on the model that we have. And the red curve would be the actual signal. And as you can see, only based on the green line, we will be able to predict a very precise strain signal after this 500 ms here. Yeah? So we would be able to predict the strain curve very precisely. In the end, we were even able to predict a cracking metal sheet. Yeah? So we actually trained them separately, and we had some classification here, which we applied. The 0 stands for the regular curve, which you see on the bottom left, and the 1 stands for the cracked metal sheet, which you see on the bottom right here. So based on this, we really had, and with the high precision sensory data that came in, we really had a great model to predict if there was a crack appearing or not, and we still had enough time to stop the press in case we would see that a crack is likely to happen. Yeah, so in the case here of the bottom right, we would actually already see after 300, 400 milliseconds that a crack would appear, and then we have another 100 milliseconds to stop the machine to prevent the crack behavior as if it would occur, shown on the bottom right here. The accuracy of the forecast was quite well. I don't have the number in this diagram here, but it was way above 99%. And also the mean error rates you can see here were quite low. Yeah, they were about 0.3, 0.4 maybe. So we would be able to save the tool. This neural networks and this AI system is actually running live now in the production side of Audi, and preventing them from various loss of income here and revenue based on the fact that we can save the tool in the case that a crack might occur. Yeah, the accuracy as mentioned before is very high, even 99.9%. Yeah, so we had a very, very well prediction here. We had a very, very high prediction rate. So we would be able to find out more than 999 cases in 1,000 cases. Yeah, and the fault prediction, which is about 1 second, can be applied to a press signal, which takes about 1.5 seconds to 2 seconds. Yeah, then we would be able, in the first second, to predict the crack and prevent damage. So with this example, I thank you very much for your attention. And now we are open for questions.
All right. Thank you, Dr. Hoffmann. So it was indeed a very good presentation. So I guess now we can move on to Q&A. From the audience, is there any questions? Feel free to unmute yourself, turn on your video if you're comfortable, and you can just ask question from Dr. Hoffmann, so that this is a great opportunity for you to talk to him or speak to him directly and ask questions regarding this data analytics and machine learning. Any question? Okay, I think the participants are quite passive today, right? Okay.
Hi. I do have a question. So I enrolled for a course in university just for fun, right? Data science and analytics. And I'm, as you know, I'm actually from Motorola. So in case of a thesis or any projects, how can I actually start looking into a project where it can benefit myself personally as a student, as well to the organization and to the industry as well? How can I actually, start a point that I can actually think through to get myself started, initiate my projects that is aligning to the department or the nature of the job? I'm actually from the product configuration management team. So we deal with a lot of data as well, right? So if there's any pointers which I can take back, that would be helpful.
Yeah, so that's a good start. Yeah, if you have the data already there, that's a very good start. And this is very important to have that, because actually the biggest obstacle for most companies to get started with AI or data analytics is the lack of data. So if you already have the data, this is very good. So the next thing is you actually need a question. Yeah, you need to answer yourself or for the company's strategy. What is actually the goal you want to achieve here? Yeah, and based on this question, then you can answer, okay, which kind of, like, let's say, AI model, machine learning model would be suitable to answer this question. Yeah, I don't know, when you say like you are in a product design, what would there be any? Do you have any problems in mind that you think we could target with AI or some data-driven models?
I'm with a product configuration management, not more for design, right? So yeah, we are continuously looking at process improvement. That could be some way which we can automate instead of manual processes. So I believe that will be the area that I would like to focus on, automation instead of manual processes.
Yeah. So then, okay, when you say you work in configuration, then I can immediately think about that we can maybe try to optimize the portfolio of different, let's say, devices you manufacture, yeah, and maybe optimize the production plan here. Maybe think about some redesign of the setup of the production line to make the different machines more approachable by the most frequent product, or to understand which configuration actually is the bottleneck in the production here. And this would be actually a nice use case here, yeah, to profile all your current configuration of products that you have, and to find out which one of these configuration might be actually the bottleneck, and basically brings down the performance of the whole factory or of the whole process. And based on this profiling, we could maybe start thinking about if this configuration is actually suitable, or we could start thinking about maybe redesigning the way of manufacturing in a way that this certain configuration is targeted better. There's actually some machine learning techniques which are immediately suitable for this. For example, what I explained before with what supermarkets already do is called market basket analysis, and this could be already targeted on these sort of configuration and automation problems.
Sure, noted.
Okay, thank you, Dr. Hoffmann and Tilagam. Right. Okay. So next we have a question from Waiman Chiang from MPC. From all the currently available software tools for data analytics, what are the few popular or recommended ones?
Yeah. So actually, we go for open source software. Yeah. So for example, when we do trainings, we go through the whole digitization. We go through the whole value chain of manufacturing and data. And for all this, we use open source tools. And in fact, the most advanced software suites, tools, and environments right now is the Python programming language. And this is also what we actually train in all of our trainings. We have some pre-training on Python basics programming. We have some intensive training on big data analytics and AI. And there we examine deeply how we can perform machine learning with Python, not only on programming, also using graphical interfaces, which are offered there, which we can use to perform our first data mining project or our first data analytics project. Yeah. So actually, yeah, to make it quick, it's Python. Yeah, it's suitable tools right now. So is your question answered by this, or you can also please feel also free to speak directly to me if you have any back question here to this. I would love to further examine.
Yeah, thanks.
Yeah. Okay, thank you again. So we have another question, but from unknown. Okay. Digitalization, especially AI adoption, is slow in manufacturing sector. Will this COVID-19 pandemic will speed up or slow down the AI adoption in manufacturing sector, where government need to create more jobs in post-pandemic area?
Yeah, my opinion, but this is, I'm not a, let's say, medical guy, yeah. So I don't have a very sophisticated opinion here how severe the COVID-19 will still be, or how much it will affect still, for example, manufacturing. But what I can say, from what we've seen so far, it can be a risk and a chance at the same time. Yeah, so you can actually use the opportunity right now to really rethink your processes. It has already worked with company communication. For all these years, researchers were claiming that we need more home office, we need more remote work. People can be more effective if they communicate in a smarter way. And now we are forced to. And I personally see many companies who already benefit from this and even get a leaner way of communication right now. And I think in terms of application of AI and in terms of applying data analysis, this can also be a chance right now. Because now you have the chance actually to look at the data that you got, to look at the data sources that you have, maybe to also redesign some machine interfaces right now, because now they are standing, some of them are standing, and you can think about, okay, now's the chance how we can digitalize, because when the next pandemic wave might come, we never know if in a couple of years this happens again. I'm already prepared to go full digital, at least for this time range then. So in my opinion, if the governments will actually do this proactive support here, then it can be a huge chance. So now is actually the best time also to learn this, right?
Yeah, I totally agree with you. I hope the person who raised this question satisfied with the answer. If you have more questions, please feel free to unmute yourself. Sorry, I couldn't address you because it only...
Yeah, I'm the one that asked the question. My name is Derek.
Hello.
Yeah, good presentation, Mr. Hoffman. But actually, Mr. Hoffman, my main concern is like that because I think if you're talking about digitalization and AI, unavoidably, he will actually reduce many traditional jobs. But now the problem is for government, because I think the government, their pressure now is, after the post-pandemic, they need to create more jobs for the peoples, not because of the science reason, technological reason, but more actually is on the social stability reasons. So if that is the case, my only concern is, will this government's, because government's concerned to create more jobs, this will actually slow down the digitalization process, for the manufacturing industry. Because if most of the manufacturer adopt AI, it will actually reduce a lot of traditional jobs. Where now the government, they need to create more jobs, for after the post-pandemic era. Yeah, that's only my question, and maybe we can get some of the view from you, Mr. Hoffman. Yeah, thank you.
Yeah, this is a big discussion, and I'm of course in no position to totally deny that AI or smart robots will take away jobs. In some way, they might even take away jobs, although I think this number will not be as significant as the criticism claims now. In my opinion, really, the AI field will first create jobs in the first point right now in order to develop all these solutions and bring them in place. And secondly, later, AI will transform jobs. There are traditional jobs, of course, that will be taken away by this. But in my opinion, these are mostly jobs which are very laborious and very difficult to perform. For example, I've been also in Malaysia in many factories and see, for example, inspection processes, quality inspection processes, where many people sit 8 hours a day in front of a microscope and stare down on chips that are processing through. This cannot be good for their health, in my opinion. And this kind of jobs, which will be maybe replaced by an optical AI system, which is even able to process the pictures better than the human eye is, these jobs might be taken away or transformed. But in my opinion, this is really for the human good overall. Because first of all, progress you basically cannot artificially deny, or progress you cannot artificially stop. You can only be the first one to deal with it in a smart way. If you say no, no, no up to the very end, and then get overwhelmed by this new technology, then you are in no position to design this process anymore. Now you still have the chance to design how you would like to do digital transformation. This is my opinion, and I would really like if the government would also see it this way. But of course, I can also see the short-term interests, which, for example, the government has right now in creating new jobs, and applying AI is actually a long-term process, of course, for every company. But again, I think now we still have the chance to design this transition, and now's the time to learn.
This is Chiang. I'm not part of the government, but I think I got some insight into what they're trying to do. In my opinion, I believe that the government is not consciously trying to slow down adoption of AI just to ensure employment. I think it's not. It's a short-term problem, right? I think the government is trying to promote adoption of Industry 4.0 because in case there's another recurrence of the crisis, they want to ensure that the manufacturing continue to be able to resume the operation and not be affected by this one. So the protecting the nation's economic to ensure that our factories run and our export continue to move despite the one is more also equally important. So short answer is they are promoting adoption of Industry 4.0 because we believe this is a long-term journey, to be competitive. Ensuring employment, we need to find a more tactical way to resolve this issue short term. Just my sharing. Thanks.
Thanks for the insights. Yeah.
Thank you, Mr. Wyman, because Mr. Wyman is from MPC EEPN, for those who don't know, right? So he's under Malaysia Productivity Corporation, right? Okay, so we have another question, Siva Shankari, right? So how we can decide which algorithms suitable to use for the issues, right? For example, NLP can adopt both machine learning tokenization and deep learning neural network. So how to decide which one is suitable?
Yeah, so there are, of course, certain measures you can identify in the data, yeah, to find out which sort of algorithms might be suitable for tackling these problems. Yeah, NLP is a very complex field, and NLP has many different phases and NLP has many different applications. So it really highly depends on the complexity of your natural language processing problem to find out if actually deep learning is needed here with neural network, or if you can still go with the classical tokenization, let's say rule-based systems. Yeah. So what I would always suggest first is that you before you actually go very, very deep into the NLP problems, you also think about redesigning your way of data capturing. Yeah, and this can be as simple as instead of giving, for example, workers or users free text fields, give them a set of predefined drop-down fields. Yeah, for example, bring them through a menu, which already many companies do with, for example, FAQ systems. Yeah, you ask them a couple of questions and bring them through a tree, and this way I can even reduce the need for NLP, which is always very complex in the first place. Yeah, and after you did this redesign of this information gathering system, then you can actually think about okay, I've still this strings, I've still this natural language components here, which I need to process. And then you really need to compare the models based on their performance. Yeah? So nobody can tell you just by staring at the data which model might be the best one. You actually need to examine different machine learning models and different also deep learning models to evaluate which one is the best. Yeah? But you can you can in fact take certain data probes to find this out quite effectively. Please also feel free to start a discussion with me if you have some more specific question in that field.
Yes, Doctor, thanks for your clarification. But actually, when I noticed these NLP analysis, so as you said, yeah, we try to redesign the text category according the menu, but still I'm unsure how I can go for the algorithms, because when I go through some research and journals, there are too many algorithms available out there. So it's very hard for me to decide which one will be suitable. Like example, currently we are having like ticketing system, right? Too many issues and tickets we are receiving. So how we can categorize it according using the description we are received from user. So such scenarios, how we can handle.
So yes, so actually, as you said it before, the NLP field is a huge sector, and there's many models which are already in place here and developed. And especially in NLP, it's very important that you know precisely in which data domain you are operating. And especially for NLP also, there is many already predefined models. There is predefined, let's say, pre-trained neural networks or predefined ontological models, which are already suitable for your design. So, and I'm sure there is already pre-trained, let's say, neural networks of processing production-related information or production-related language, because you have a certain terminology there in, for example, manufacturing, and you have a certain type of words and a certain type of compositions of words that are used. And please look especially for domain ontologies there, to find a namespace which actually suits your application area. Otherwise, it's hard to find a suitable NLP algorithm. I could not agree more here. It's just one of the biggest and one of the most complex fields which is out there in the market right now.
Okay, Doctor, noted.
Thanks.
All right, thanks again. Okay, I have a question here, Dr. Hoffmann. So this is just for for students and also for someone who like to be to embark, or I would say would like to make a career change, right, into data science or data analytics. So could you briefly explain the difference between data science and data analytics? Because there's a perception people think both are same, and because data analytics is more like a part of data science, and data science is like a bigger umbrella. So could you give an explanation about this? What are the skills required to become a data scientist?
Yeah, so as I already mentioned, I think 2 talks ago, data science is a huge field, and data science is never a one-man show. Yeah. And especially what I said before in with the NLP problem, with the NLP system, you always need process experts, domain experts. You need experts for different areas, let's say machine-to-machine communication, language representation, sensor data integration, and then the analytics part, the database part, the storing, the curation part, and so on and so on. So data science is the whole science actually behind dealing with data in a very, very broad view, in a very overall view. And the data analytics is only it's the actual value creation part of this big data science process. But it, of course, requires that you already have your data in place, that you already have your data appropriately pre-processed by the help of these domain experts who understand the field and understand the processes. And then when you have your, let's say, clean data, which is ready for the analytics, then you can apply data analytics, for example, data mining techniques or some machine learning techniques to actually find these patterns in the data. Yeah, and the data analytics part, you can actually learn quite easily. You can also learn them without having a practical use case in the first place there. Yeah, you can also train them with some data sets which already exist. So you can already make yourself ready for the time when the data is there, when the data is ready and ready to be processed.
Okay, thank you, Dr. Hoffmann. So let's see if we have any other question from the chat box. No. Any other questions from the floor? Okay.
Yes, this is Lingesh from Monitor ERP Systems. Hi, Dr. Hoffmann.
Hi.
Yeah, okay, my question will be, this is quite a common question, I believe, because if you look at the OEMs or MNCs, typically they have their own roadmaps in terms of technological roadmaps and 3 to 5 years where they want to be. So for them to get into machine learning and AI and so on is actually quite fine. But how about these tier 1 companies, tier 2, especially SMEs, when they want to get involved in AI or machine learning or data analytics, it's quite hard to influence the management. So the first question they'll normally ask, what's the return of investment in these things? So from your perspective or your experience, how do you actually approach these kind of companies? Because for instance, the Audi example you showed earlier, of course, it's nice to see, okay, it's a deploy process and you may have failures in your tool. So you take that into account and look at, okay, if I do this kind of analysis, we can save some amount from this point of view. So for SMEs, normally they do not have this kind of roadmaps. So what's your best approach? Is it like you do kind of simulation and show them first, okay, this is how much and so on in terms of returns you get, and then we move forward, or what's the best approach?
Yeah, so I'm sorry, first of all, if there's some background noise here. I think my neighbor is digging a hole somewhere. I don't know. Okay, so yeah, thanks for this question. Yeah, I get this question actually quite often. In fact, after each of the talks, I get this SME question, which is of course very, very important and one of the most important ones, because companies like IBM, we don't need to support here. Of course we can, yeah, but they have their roadmap and they have their ideas and they have their and they have also the money they can put down to realize this big and huge roadmap which goes over the next years to make some major changes. SMEs don't have to do this. So, and my answer to this is clearly SMEs, even though we cannot precisely predict the OEE optimization or the return of invest here, OEEs needs success stories. And these success stories can also be brought with a limited amount of money or a limited amount of investment. Yeah, a success story can be already brought by placing for example, Raspberry Pi device, a small computer device next to a machine or next to a sensor, capturing the data in a smart way, and then actually trying to find some patterns in the data and giving only some, let's say, decision-making support. Yeah, let's say we analyze this data which we capture, and the only thing we do with our prediction model then is tell the worker, give him a few recommendations how to optimize the machines in certain stages. From the technical investment point of view, this is very low weight. Yeah, there is some knowledge, of course, involved here. We need the calling, let's say, 2-3 persons who are part of the data science team, one for the data capturing, the other of the data integration, the next one for the the analytics and the deployment. Yeah, so we actually need this team of data scientists to realize such a project. But with these little demonstrations, I think every SME can also see the value which will come in the very end, and they can have their first success story and their first showcase here. This is the only answer I can give here. Yeah? And my suggestion is, of course, even SMEs don't have the power to transform their whole organization in a couple of months or in 1 or 2 years. They should take the opportunity, especially right now with this at least partly or even completely funded programs. Please, Bragawan, correct me if I'm wrong. You should take the opportunity here to get yourself trained, yeah, and to get the first step into this data science.
Yeah, thank you, Dr. Hoffmann.
Hello.
Hello.
Yeah, my name is Derek here again. Can I ask Dr. Hoffmann another questions?
Yeah, of course.
Sorry, Dr. I saw your slide here. You are from Faculty of Mechanical Engineering. Are you a mechanical engineering background?
Yes, I'm originally a mechanical engineer, but I did my diploma already in 2010, so 10 years ago. And then I was some years working as a consultant and decided to make my PhD in IT. That's why in the last 6-7 years, I'm heavily in IT and basically I did myself some transformation, let's say, yeah, from mechanical engineering background to IT background, and now I feel kind of home in both worlds.
I see. Actually, because I'm also actually mechanical engineer background, and currently actually I want to shift to AI, because I think mechanical engineers, they have been, Industrial Revolution 1, they have been the main character, but IR 2.0, 3.0, even 4.0 now, they are actually, it's like become a supporting role, So my question to you is, Dr. Hoffmann, is being a mechanical engineering background, if you want to go for AI, especially on Industrial Revolution 4.0, what do you think is our biggest strength, and also what is the biggest challenge, for us as a mechanical engineers?
Yeah. Thank you very much for this question. Very, very good question. And I think you're totally right. Yeah. The classical engineer was the value bringer in the old industrial times. And it's a very good question because actually it's, of course, quite hard for an engineer to start out in data science because he has no, let's say, native IT background from his field of studies. But the engineer has a major advantage. The engineer speaks the language of the engineers and can learn the language of IT. And this is also the biggest problem with IT guys. IT guys often cannot speak the language of engineers or are even let's say disregarded by the engineers because they don't understand the process so well and cannot go down on the same level of discussion on the basic mechanical setup, let's say, on the sensory setup and so on. But as an advantage you have as an engineer, actually, if you're able to learn IT, which you will be, I'm very sure, because the methods to do this now are amazingly simple and amazingly well developed, then you will be able to be the translator in your company, to be at home in both worlds. And I've seen this as a major advantage. Yeah, also being able to talk to the engineers and also being able to convince the engineers about, let's say, new approaches. So if you ask me for the major disadvantage, I don't even know exactly what to say, because usually an engineer is characterized by a very diverse academic background. He's learned math and chemistry and physics and everything. And so he should be actually able to also dig into IT systems quite well. Yeah. it could be a disadvantage, of course, when you are, I don't know, like many years in the engineering field and never dealt with IT systems. But even then, I think with appropriate training, you can get ready there. Yeah. So for me, the advantages of like being home in the engineering sector and also speaking or learning language of IT is a tremendous chance for every engineer, which you shouldn't miss.
Thank you, Dr. Hoffmann. I hope, Mr. Derek, thanks for the question. Because this is a good question. Why? Because most of the companies right now, the manufacturing companies, engineers are with the electrical and mechanical background. So they are quite, reluctant and hesitate, because they didn't practice programming or IT subject for many years. But based on your question and the explanation given by Dr. Hoffmann, I believe, it is not impossible, right, to shift from from an EE or ME engineer to, someone who knows data analytics, programming, and so on, right?
Let me add one more point to this. Actually, many engineers are afraid of IT because they think it's very hard to start out and it's very hard to get started. But especially in the last 3 to 5 years, I have seen the development and I have seen the development of the field. And I have to say, the tool set and also the open source tools, which you can use for AI now, data analytics now, have become amazingly simple in comparison to, for example, only 5 years ago. So the picture you have from IT, if this is 5 or 10 years old, it totally does not reflect the ecosystems that we have right now. Now you can even start out with graphical programming. For example, in one of our classes, we're using this Python library called Orange. And with this library, you have a graphical interface where you can drag and drop your data sources, connect them with each other, and be able to derive a machine learning model which can actually make a very smart prediction without any programming skills. Yeah. Of course, when you want to go deep into the machine learning, like NLP mentioned before or something else, then you also need to learn some programming. But this is usually just a few lines of code, yeah, which you can really learn and which you will learn in a couple of days in my class as promised. Yeah. So don't be afraid of IT. It has changed. It has become so approachable in the last years, and I can encourage anyone from 25 to 65, yeah, to learn this. Yeah.
Thanks for the additional comment or points, Dr. Hoffmann. Yeah, I think now employees, students, or whoever it is, they have a better picture or clearer picture that they can learn things easily, due to available open source programming language or framework whatsoever, right? Okay, so we have 12 more minutes, but we don't have any more questions. Right, so we don't have any more questions. So is there any question from the audience? Anyone would like to unmute yourself and ask maybe a last question to Dr. Hoffmann before we wrap it up? Anyone? Okay, I don't see anyone is turning on their mic. So with that, thank you, Dr. Hoffmann, and thanks to all of you who have participated. I hope this talk really benefited you guys by all means, right? So ladies and gentlemen, this talk is brought to you by Steerix, MPC EEPN, and MGCC, right? So we have another 2 more parts. This is part 3. So part 1 and part 2 is available at our YouTube channel as well as our Facebook page. The links are in our chat box. So part 3 recording also will be uploaded soon in our YouTube channel. And for part 4, we will be emailing you guys. We have all your details, your email address based on your registration. So we will email you guys the part 4 invitation or flyer registration link so that and I hope to see you guys again in part 4 and part 5, right? And thanks for those who are participating from since part 1, and those who participated newly in this part 3, please join in part 4 and part 5 as well, all right? Don't miss the chance. Okay, so if you need any assistance, kindly email us at info@steerix.net, right? It's also available in the chat box. Okay, thank you everyone. Thank you, Dr. Hoffmann. Take care and stay safe.
Thank you very much. Goodbye.
Bye.
Thank you. Bye-bye.